So our goal in this class is to determine what is the true average of a data set. So our true average of a data set we'll talk about as being x prime, where x prime is equal to the measured average, x bar, plus or minus some uncertainty with some type of probability percentage. Okay, so this probability percentage is our certainty that the true mean lies within this range here. Okay, so um, in our case, we're going to say the uncertainty is due to just random error, um, uh, and in order to understand our data set um, as a better, what we can do is we can create a probability density function. Okay, so the idea of a probability density function is that as we take more and more measurements, the values will typically cluster around some type of central value. So for example, we have a set of random variables shown in table 4.1, and you can see that in the middle region of this data set, we have a clustering of variables. Okay, um, so instead of using a number line like it's kind of shown on the bottom here, a histogram is a much more common way to show that data. Okay, so for when you make a histogram, the one thing that you should need to know is what is the appropriate number of bins to use in a histogram. So if you have for small numbers of data sets, so if you have data that's in between, you'd want to, if you have a small number of data points and you would want to use a small number of bins. Okay, so um, all right, for larger numbers of data points, all right, so I think this should be a less than sign, greater than or equal than sign. Sorry. For a moderate number of bins, you want to use this number of bins here. All right, and then if you have a very large data sets, you'd want to use k is equal to the square root of the number of data points that you have for your bins. Okay, so the whole point of doing a histogram is you'll see the shape of your data. So I'm going to show you how to do that in a second with an example, but I'm going to skip the example real quickly and go to the next point. Okay, so if we're able to get a very large sample size, so we have an almost infinite number of points, we can create a continuous function, which we call a probability density function, p of x. All right. So if the change in our variables x becomes very, very small, we'll get this continuous function described this way. Okay. So our probability density function statistically models the population of a variable. So what it does is it defines the probability of variable may assume a value for a particular measurement. All right, it will determine what is the central tendency or the best representative of the true mean value and the variation distribution of variable relative to the true mean value. So on the table below is a list of different types of common PDFs. The most common and the one that we'll focus on for this course is the normal distribution or the Gaussian distribution, the same thing. So it's probably the most common and occurs most naturally. But you can see is that depending on your data set, maybe it'll look something a little bit like this. So if you take the histogram of your data, you'll get to see which would be the most common in for your data set, and you can pick that one to best model that data set as a continuous function. Okay, so so basically your procedure will be create a histogram, estimate the probability density function based on the shape of that histogram. All right, and if you can do that, you can then create a continuous function. And you can determine what is the mean value and the standard deviation using these two equations. If you just have a numerical data set that's large enough, you can use these two values to estimate the mean and the standard, the variance. So again, if you know the variance, you can take the square root of it to determine what is the standard deviation. And So the problem with these relationships that we have here is that the shape of the entire data set. So often we don't have that much data available to us, so we need to make some assumptions based off of a smaller data set, and we'll talk about how to deal with that. So in order to do that, we'll talk about that in our next video. I guess in the 2 videos. The next video we'll talk about is how do you make a histogram using Excel.